Hello everyone, myself Balavikram Tadikonda. So today I'm here to present our Smart Nights 2026 paper, Governing Clinical AI in Obstetrics over here. This is a joint co-work with my authors, Mahendra, Vineet and Vijay Kumar, and I'm presenting it solo today. So in next 10 minutes, coming down to one idea, we are building obstetrics AI to chase accuracy and also we are leaving safety behind. So let's deep dive into this delivery room over here. So during the labor, emission called cardiograph or and also like CTG records, which tracks the baby's heart rate, and also AI tools that reads the signals from signals also over here. So and also based on those reading of the signals, it turns into a kind of like three buckets, which is called normal, suspect, and pathologic. The two ways are being wrong are not equal, which means like all a truly pathologic case is normal, and you can delay on emergency delivery also. And also cry wolf, the other way is like you can push a mother into cesarean when there is no necessary also if the stakes are uneven over here, you had to expect the research to be obsessive about the safety. So I went and checked. Here is what I found out here. So there are three things which I have based on my findings, which we had found is like one is a kind of like systematic review of like 38 real studies over here, which we encountered out of 38. We had used like four basic controls to show up. Two small cases study are on the heart fetal rate over here, and also that shows like high accuracy score, and also on top of high accuracy score that can hide the failures and most of the matters this situation over here because of the hiding of the failure. So and next three are a kind of like governance framework that turns standard every sites into checks you can able to run. So let me start with our review. So over here, we had run a Prisma review across like a Pumate, IEEE Explorer, and Google Scholar covering from 2015 to 2025 over here. So we started with a 500. We started initially with a 524 records of papers over here, and narrowed down into 48, and then into kind of like 38 empirical studies over here. So we scored each one into eight governance dimensions and also focused on four checks. So what are those like did that what are those like did did they test for bias launch means like bias, did they validate at more than one hospital, did they say who is accountable after launch, and did they keep watching once it was live over here. So that's the floor before you let the software near your delivery room. So how many studies has been cleared over here? So almost none of them have been cleared over here because out of 38 studies over here, only 13%, if you take a close look, 13% are like a kind of like models are biased. And on top of that 24%, which is of like a nine case studies out of 38 are tested on more than one more sites. And additionally, 18 percentage is who is the responsible once if it's deployed. And last but not the least, like 16% is had a plan to watch and watch the model after the launch. So unknowingly, 84%, if you take a close look, is like 84% has no post deployment monitoring over here. And also this wasn't a kind of like few weak papers. It held on more all type across all model question types, clinical areas, and also countries, which is very systematic over here. So now let me show you what was the one of these gaps does the real patients need also. So over here, we built a sample case study of a public heart rate from the UCA, which was taken of the data from of data over here. on which like we got like 2126 records and 21 features over here. So we trained a logistic regression and random forest model on macros F1, not, and also over here it is not an accuracy also, because the rare class is the one we can't afford to miss it. So one more thing is like these labels are expert opinions on the trace, not on the hard clinical outcomes over here, like core PhD blood group, and also there are some more like some of the teaching examples which over here. So now watch what is the accuracy headline heights over here. So if you take a close look, so So if you take a close look over here, the random forest model hits 93.9% accuracy, which means like, do you feel like it sounds great? But in macro F1, 0.89, and on top of that, on the pathological class over here, if you take a close look, the false negative rate was about 13 percentage. So in this, if I tell you in simple terms over here, roughly one in eight pathological case was got labeled over here as a fine. Means like in one every real unit, we need to deliver 200 deliveries in a month. So that means like two or three sleeps through every month, which we used to get. Here is the way we kicker over here. Means like a model that just says only normal to everyone already scores 77.8 percentage, which is similar to 78 accuracy, while exactly catching zero dangerous causes over here. So you mean this is a kind of like accuracy which is a mirage over here. So which means like big numbers and blind to the cases that matters over here. But maybe it still beats a tired human at 3 in the morning, and let's test it also. So if you take not really over here, it's not about even or else like it's not about anything over here. Our random forest landed across like 87 percentage if you take a close look sensitivity. So right in that range of like CTG while following like CTG standard guidelines like NICE, FIGO, SVA 17 also. But this is a kind of like which is similar to apples to oranges comparison. Those guidelines are measured only against the biochemical outcomes, and also our model predicts only a label someone who wrote down. And so the problem is real over here. The model isn't a savior also, which leaves the one question matters: what do we do about this? So here is what we had introduced a proposed framework over here. Uh, a safety framework that also follows the model across the whole life cycle. Means like this framework is divided into four partitions. Like in first phase, it is a kind of like pre-model auditing over here, which means like we need to be the representatives checking before checking your data, and also if there is any data leakage also we need to audit that over here. So while taking these considerations, we had found like what happens if it's a kind of like multiple websites. So here is what the second site which we second phase comes into existence, which means like yeah, it is a kind of like stress test. Means like we need to validate more than one hospital and also hold the pathological recall and also about 90 percentage over here. This is what we need to check over here. So while doing these two situations, we understood one thing is like who is accountability over here. Here is what the third phase comes into existence. Like name of the human who is accountable to log every time a doctor overrides the model over here. This is what over here we had introduced. And last but not the least, we while doing this we need to verify, we need to check every time over here whether how the monthly performance rate is also happening. So here is where most of the people used to miss this is the main phase which I we feel it is a main important over here. See, means like we should keep watching it, and also monthly checks, and also additionally automatic reviews for the moment a pathological recall drops below 0.85 percentage or not. If you forget the rest, hold on at least like 3 lines. This is where we need to important over here. So, what are those 3 lines? Means like those 3 lines are like before any obstetric AI goes into live, we should validate whether multiple sites are having like a kind of like real bias analysis or not. If yes, we need to put the name of the people who hook up for that accountability. And secondly, like who keeps monitoring after the launch. And last but not the least, let me be just honest about why this is not working over here. It's like the framework is proposal only. It's not a piloted. It's not yet piloted because the reason is like the scoring tool we use isn't formally validated, and the case study uses only proxy labels from one data set. So I'm telling you that upfront. So because over here, when you start being over here, you can use your own limits. That's what over here. So finally, we can able to mention is like obstetric AI is a kind of like faster moving than rules mean kept to it safe, and also a model that is 93.9 accurate and also still misses 1 in 8 pathological cases not a safe by default, which we feel because the headline numbers look so kind of like good, but safety has to be built into the life cycle, not like bolted to the end. Thanks for watching this, and thanks for smart nits for reviews. And I'm happy to share my reviews over here. Thank you so much.